again, my name is Bruce Erickson, and Mark Reuter's here to stand up. If anybody's called in to Ziegler asking about some of these emission rules and things like that, you probably talk to Mark. And again, we certainly can answer questions here if something comes up as we're talking, as well as after the session as well. So what I'm going to do is try to give an overview of some of these emission rules that have been going on in the generator, kind of diesel generator world over the last bunch of years. And I just want to make you know it's a complicated subject. I sort of got into it, a couple of years ago. This NESHAP rule came out, and I said, well, shouldn't the average guy should be able to read one of these rules and figure out how it works? And I started reading these things, and it was like 200 pages long, and I was in my office for like 3 days, and I still don't quite understand it yet 3 years later. So it's pretty complicated, but what I really want to do today is to talk about, to kind of make this complex subject a little narrower and focus in on probably the things that apply to most of the people in the room. Not talk about the edges of the rules and all that, so kind of focus. A little echo here. And so, there's a lot of things about major sources of emissions, and again, my belief is if you are a major source of some emissions, you know that already. You have some special permit or something. If you don't have one of those, you're probably not a major source. So we're going to talk about area sources and the kind of general things that apply to people. It seems really loud, doesn't it? I mean, so just me. You're fine? Perfect. It's now better? Yeah, I was going to say. So I'll give you a little bit of kind of general background on the rules, and then talk about some of the rules and how they apply to new purchases, new generators, new engines that are being bought in the first part. And then we'll switch over to talk about rules that apply to existing generators, things that you already have installed, which is kind of a new thing and how they've been doing this. So just a little background and the like. So, the really long background on this is that the EPA, and this is all additions on to the Clean Air Act, which was enacted, I think, in 1960 or something like that, back in the 60s. So these just kind of add-ons and add-ons and add-ons, and the numbers and the rules just keep getting longer and bigger. But as far as diesel engines go, they started first with regulating on-highway trucks. And so if you have trucks, you know what, kind of on-highway trucks, they've done more and more things to reduce emissions. You've heard about diesel emission fluid or urea that might be in some of the brand new trucks. But those are the first place the rules went on. Then the next place that they started adding rules to reduce emissions for diesels were in non-road mobile, or like construction equipment, road graders and bulldozers and things like that. Things that moved but didn't run down the road, down the highway on a regular basis. And then the last thing that they started adding these rules to were for stationary engines. Again, generators is what we're going to talk about mostly here, but it'll be fire pumps and irrigation pumps and things like that where these rules have been applied to as well. And the EPA's got a whole bunch of stuff that it regulates. The main things that are related to engines and diesels are listed up here: carbon monoxide, hydrocarbons, particulate matter, NOx, and hazardous air pollutants. And so if we look at a chart, this just kind of says, as far as diesel emissions for a generator, before there was any regulations, there was some amount of, this thing shows on one side, is particulates or smoke that you see coming out of a diesel engine. On the bottom, it's NOx, nitrogen dioxide, nitrogen trioxide, those kind of things. And so the regulations have been put in place to kind of gradually, groups of years by years, to put out less emissions from new engines. And so as you can see, it's driven it down to where we are today, beyond 2011, this thing called Tier 4, where it's like 98% and 98% reduction in particulate matter, smoke, and then 97% reduction in NOx. So big reductions over time, and it's happened kind of gradually, and it's happened in different time windows. This is really the kind of the picture for the diesel generators, but if it was a diesel truck, those dates would be earlier than that. And like I said, and for non-road mobile, those dates were earlier for that as well. So Another thing I want to talk about just in general that applies to both new engines and to existing engines is kind of how we use the engines. And you know, for me, being in the generator business, and probably for a lot of you too, it's like, well, I got this engine out there, it doesn't really run that much. It's kind of a standby engine. It's you know, it's on my utility peak shaving program, but it doesn't run that much. It runs a few hours a year. You know, yeah, it's emergency, it's standby, it's peak shaving, it's whatever. It's, you know, again, those are all things that we talk about these engines, you know, at a lift station or at your facility or whatever. It doesn't run that much. I mean, clearly there's something else, you know, kind of prime power, stuff that runs all the time. It's out at an asphalt plant or sitting out someplace where there isn't utility power. And that's sort of the other category. So we've got engines that run a lot and engines that don't run very much. So that's pretty much how we all kind of talked about it. But then in the EPA, in making these rules, they, you know, kind of had to define things differently, or they had to make a better definition, I think, because that's much differently. So the EPA, and again, we'll talk about this for new engines, we'll talk about this for existing engines as well. The EPA says that an emergency engine is an engine that only runs when the power goes out. And so, again, you have an outage, the engine starts, that's fine. And as far as how long you can run that, you can run it however long you need to, as long as the utility power is out. So again, for those guys that were out in you know, on the East Coast for Hurricane Sandy recently, you know, they lost power. I mean, they could run their generator for 3 weeks, 4 weeks, you know, month, 2 months. Their emergency generator would still be classified as an emergency generator, even though they might have run it constantly for 2 months, but because the utility power wasn't there. So that's what an emergency generator would be. It'd be the same for us, and you know, again, an ice storm or something like that happens, and the generator comes on and runs. So, like I said, the EPA, the way it defines it, there's no limits on the hours of operation for emergency use. Then they also know that there are times that you need to test your emergency engines so that they'll work right. And so EPA says, well, you can run your emergency engine for up to 100 hours a year to do testing, like according to the manufacturer's definition of what you need to test, or according to whatever your association rules are. I think of hospitals where they have specific rules about testing their emergency generators. So again, EPA said that's cool. Emergency engine only runs when the power goes out. When power comes back on, it stops running, and it also runs to do testing. That's kind of what it's got. And then really the other side of the definition is that everything else is called non-emergency. So in a lot of cases here, I mean, if you're on a peak shaving program with your utility, a discount program where your utility might call you to run for certain days where there's more power need, you know, again, sometimes it's the hot summer days, sometimes it's the cold winter days where there's a lot of electric heat that utility has. So that's the main thing where you know, you can sort of be non-emergency. And again, the definition says that, I mean, if you're on a program to get paid by your utility, if you're getting an incentive to run your generator, that's non-emergency. Even if you don't run your generator and you got that incentive, it's there. Even if you run that generator for 1 hour during the year, because of that, it's non-emergency. There's some other things that would be classified as non-emergency. I mean, sometimes like casinos, if they have some power glitches and things that happen during thunderstorms, some of them might turn on their generator when a thunderstorm's coming into the area just to make sure they don't have any power glitches. That again would be kind of a non-emergency. The utilities running their generators to put on the grid, that's non-emergency. But again, for us, most of us I think here, I mean, again, if you're on a utility program, if you're getting a discount on your utility rates because you have a generator that they could call to run sometime, that means that they're non-emergency as far as the EPA's definition goes. So, like I say, we're going to talk first about new engines and then about existing engines. So there's a couple of ways that I'll say this at the beginning, I'll say this at the end to remind you, but when you hear people talk about, because sometimes these two topics get mixed together or confused together. So when you hear people talking about tiers, engine tiers, tier 1, tier 2, tier 3, tier 4 interim, tier 4 final, whatever. I mean, that's for new engines. The rule I'll explain is new source performance standards. And the rule really is looking at reducing two main things, like I showed in that other chart, reducing NOx and reducing particulate matter or smoke out of the diesel engines. So that's the focus of those rules. The second part of the presentation we'll talk about is existing engines. And we'll talk about how the EPA made a rule, kind of for the first time to do that. And that rule is called NESHAP, and it really is focused on reducing hazardous air pollutants. So it's really looking at reducing a whole different set of emissions And there's different sets of rules that go with that. So again, I'll remind you, we're going to go talk first now about new engines and the tiers and things like that. So most of the stuff is kind of just long and windy, but NSPS, that, for us to talk about a lot, say it really fast, New Source Performance Standard. It's just another part of the rule from the EPA that was applied to these engines gradually over time. That's how that chart I showed you gets smaller and smaller as far as what's being emitted. And it really says something like, again, in the highlighted words, standards apply to new sources after the source is proposed. So that, again, there's a time frame. It says in the year 2011 we're going to have this level of emissions. In the year 2015 we're going to target this level of emissions. I kind of do this for a couple of reasons. I mean, without going in, I said make a complicated subject easy. Well, this doesn't make it easy, but this chart just goes to show me, it's like, unfortunately, the EPA doesn't have the same emission level. If you say a Tier 2 engine, I mean, this is kWs, less than 8 kW, something that goes all the way up to 900, 2,000 kW, greater than 2,000 kW. And there's different time windows. The colors, like red is Tier 1, this orangey color is Tier 2, the yellow color is Tier 3, green is Tier 4. And so there's different times for different sized engines, and there's different amounts of emissions. Again, I'm not going to talk about it, but right here it says 2.0 NOx, and right here it says 3.5 NOx, and right here it says 0.6 NOx. So even though all these engines are Tier 4, they have a different amount of emissions that have been allowed through the rules. It just means that for the engine manufacturer, it takes different amounts of stuff to make them apply. But one thing I want to highlight, the reason we talk about emergency and non-emergency, before 2011, you can see all these all were solid colors. It's like it didn't matter what you did, you just bought the engine. But you see down here, and I'll use kind of this. In 2011, there's this little slide down here. I know you can't read it, but this says emergency application. It says after 2011, if you're doing non-emergency, you have to have this Tier 4 emission level. But if you're doing emergency only, you can use a Tier 2 emission level, this orange color. So now it gets more complicated starting in 2011. And you can see, again, maybe you can see, but there's this colored stripe, on all these things, 560. There's a colored stripe that starts in 2011, greater than 130 kilowatts. There's a colored stripe that starts here, greater than 37 kilowatts in 2012. There's this extra stripe that covered 19 kilowatts and above starting in 2013. So we got all these places where you need to know how you're going to use the engine to know what emission standard it has to meet. So before 2011, this thing was pretty easy. Only the first bullet applied. Really, the EPA went to the manufacturers of engines, went to Caterpillar, went to the other engine manufacturers and said, you need to build engines that are certified to meet this particular level of emissions. And so really, if you went to your dealers and bought a new engine, I mean, they had to kind of have the right engine to sell to you. You didn't have to worry too much about it. You didn't have to worry about it at all, really. But like I said, as of 2011, when you come to Ziegler to talk about buying a new diesel generator, and one of the first things that we would say is, well, how are you going to use that engine? Are you going to be on your utilities peak shaving program, or are you going to just use it for emergency only? And the reason we ask that is because Caterpillar and the manufacturers have two different emission solutions engines that they are selling. Kind of the older, less clean engine, a little less clean, Tier 2 engine for a big engine, or Tier 3 for a smaller one. And they can sell that to you today if you're just going to run emergency only per the rules. And then if you want to be on the utility peak shaving program, well, then you have to step up and get the cleaner engine, the Tier 4 engine. So again, it's a discussion that happens and that didn't have to happen, 2 years ago when you're talking about generators. The other thing I'd like to highlight, and I'll show you some pictures in a minute, but the manufacturer has to certify these engines with the EPA. So some of these things, I've seen stuff where people say, it says that this engine is verified to put out Tier 4 levels. Well, verified by who? I mean, again, it doesn't matter. Does it have an EPA certified sticker on it? And that's really what, make sure that, again, the things you're buying are like not verified, but actually certified by the EPA. So you can ask the manufacturer for an emission certificate and say, here, show me that it's EPA certified. Or you can look on the engines. I'll show you a picture here in a second. Just some labeling on engines that, to highlight that. So as I said, I mean, Tier 4 is the place where these kind of the rules came out, those bands where you have to decide about, is it emergency or non-emergency. And so in kind of mediumly big and big engines, again, it says that non-emergency engines manufactured after January 1st, 2011, greater than 175 horsepower, they must meet Tier 4 emission levels. And again, that's non-emergency, so if you're an emergency generator, that's fine, you don't have to. And again, if it was manufactured some other time. There's also another set of rules. I mean, I'm not sure why the EPA didn't, there's lots of numbers, why they have Tier 4 and then Tier 5, but no, they have Tier 4 interim and Tier 4 final. I don't know, it makes sense. But so there's additional rules that are coming on in 2015 that even tighten these things down further. And as I said before, there's a lot of different specific emission levels for the different sized engines. And it just happens that for whatever reason, generators greater than 900 kW are the place where the emission levels are the smallest at kind of this current level. So you'll find that if you need a bigger engine, it's got more emission control stuff on than if you needed an 800 kW engine today. So the EPA is trying to get these emission levels way down. The emissions are so low that by the time Tier 4 comes, Tier 4 in the kind of the final level of these emissions, what they're really trying to do is put a bunch of after treatment on the engines. And mostly from Tier 1 levels, Tier 2, Tier 3, the engine manufacturers have been able to change what happens inside the engine, change the timing, change the fuel, change the heat, doing a bunch of stuff that I don't know enough about. But to just kind of modify how the engine operates to meet these emission levels. But when you get to Tier 4, it's like, okay, now you can't modify the engine enough to get that to happen. So now it has to be things that are being added on top of the engine. So you hear these kind of words, and again, it depends on what level and how many things need to be applied. It depends on the manufacturer. But I think as we get to the final levels in 2015, it's almost like everybody's going to have almost all this stuff. But a selective catalytic reduction. That's kind of things that are on-road trucks today, where you spray urea into the exhaust stream to have the NOx change into something nicer for the environment. There's also diesel oxidation catalysts, and we'll be talking about oxidation catalysts again when we get to the NESHAP, but it kind of changes CO and other things. Diesel particulate filters are the first two things are kind of chemical things that change the chemistry of the emissions. The last one is really just a filter. It's filtering out the ash and smoke and stuff that's coming out of the diesel. So these are all things that, again, unfortunately, you haven't had to deal with in the past, but someday in the future, probably, we're going to have some of this stuff on the engines. So one of the downsides of all this, of the higher emission levels, is that things cost more. So the engines themselves will cost, again, it probably ranges, but here it says 35 to 45% more. So that's where that discussion I talked about before on buying a new engine. Are you going to get a utility program? No. Well, there's an engine you can buy that costs 35, 40% less than if you were going to be on your utility program. Again, your utility program gives you savings, but now it's a bigger cost that you have to offset for those savings. Other impacts, again, there's more space required. Again, early on, maybe not too much space, but later on, when you have emission, if you have tanks with urea, stuff needs to be warm, you need to have another fluid, maintenance costs, complexity, just more stuff that has to be dealt with. I said I would show you a little bit about labels. So I've got a couple of pictures of 2011 engine labels from Caterpillar engines. If you look at this label, you can't quite see, I blow it up one notch further just so you can, I'm really just taking this piece right here and blowing it up so you can see it. Hopefully many of you can see it. But anyway, it says the power is 3,634 horsepower. That tells you what size emission band it goes into. It says that this engine conforms to 2011 US EPA regulations, but for stationary emergency only. So this engine was built to only run for emergency use. So this, like I said, now the engines have on there, this engine's for emergency use only. And as I said before, this is the same chart I showed you, greater than 2,000, that was a 3,000 horsepower engine. So this said down here, in 2011 it was built, and it had to meet tier 2 levels. There's that color tier 2, there's tier 2, it kind of says how much emissions it can put out. So that's for emergency only. That's what the label looks like on the engine. So again, if you have these questions about, I'm going to buy this engine, or I have this engine, or what kind of label, what does it have on it? Here's another label. This is a tier 4 interim engine. Again, I'll blow this up a little bit. This just looks a little bit different. Here it says it's in a power category of 560 to 900 kilowatts. And this one says it complies with U.S. and California regulations for 2000 non-rolled stationary diesel engines. This engine has been certified by the EPA. So this one, again, 560 to 900. That's right in here. It was built in 2011. And it says it's certified, so it's not emergency only, it's up here, it's certified, and that can be run as much as you want. It doesn't have to be run only for emergencies, it can be run on a peak shaving program, etc. So that's just, again, kind of a couple of the examples of labels and engines. The engine manufacturers are working to apply and get these emission systems there. I mean, a couple of these are kind of a little more kind of aftermarket or things, kind of big emission things on top of engines. This is kind of a smaller, in between size 1 would go on top of an engine. It's kind of like it's a combination muffler and the emission system. If we go to big engines, Cat big engines, I mean, this piece on top is what the emission module looks like for a large engine. Again, this other stuff would normally been there, generator, an engine, radiator. And then, here, trying to keep the package size similar size, it's a whole emission module. I know it doesn't show it here. This is the exhaust going into this module. Here's one of the output ports. There's another one on each side, so the output exhaust will come out here and go up. But the other thing that's needed, I mean, it shows you some things. There's an air compressor and a urea tank that's needed to be somewhere to be injecting some of these emission fluids into those kind of engines. So that's, again, simple, right? But that's a simple version of new engines. So I don't know if anybody think of any questions sort of on the new engine side of things. Otherwise, I'll move on to your existing engines. All right. So now we're going to look at another rule the EPA came out with, and it's called NESHAP or Rice NESHAP or whatever. But NESHAP stands for National Emission Standards for Hazardous Air Pollutants. And again, like I said, if you can't sleep at night, go on the web and look for EPA 40, CFR part 63, subpart ZZZZ. Actually, if you put in EPA and ZZZZ, I mean, there's all kinds of stuff will come up. And you can see, like I said, to me, I look at this and go, man, this is crazy stuff. I mean, they've added on subparts to this rule and gone through the alphabet not once, not twice, not 3 times, but 4 times. I don't know what the rule is for A, but it's out there, I'm sure. Because this has been out there 3 years, so there's got to be rules after this. So, it's crazy stuff. I mean, like I said, just add another number, I guess. So, anyway. For this rule became official, came out on May 3rd of 2010. And as far as we knew it, as watching some of these emission rules and talking to Caterpillar corporate headquarters and things. I mean, this is really the first thing in our world where the EPA came out and said you have to do something. You may have to do something to an engine you already have. There's all this stuff about new engines I talked about before. I guess the thing I didn't really make clear is that, the EPA has sort of said you have to follow the rules that apply at the time you buy the engine, or the time the engine was made. So, okay, I bought an engine in 2006, and it's a Tier 2 engine. There's nothing in any of those new rules that say you have to go do anything to upgrade that engine. It's fine, it's grandfathered in and met the rule. It's again, when does the EPA come and tell you that you got to go into your garage to 1970 Corvette or something, and now go put a whole bunch of emission control on it. That's my old car, my old Camaro I got in the garage or whatever. So here's one that they did do that to it. So okay, this is something we're going to have to go back into older engines and make changes. The thing, but again, they're focusing someplace else. Hazardous air pollutants. The EPA would go in their whole justification and say these are the things that cause cancer. And there's 189 chemical compounds that the EPA says are hazardous air pollutants. But in diesel engines, it's primarily formaldehyde that is an output of a diesel engine, and that's what they're trying to reduce. And yet, when we start talking about all this stuff, they talk about measuring the CO, the carbon monoxide coming out of the engine. But it just turns out that carbon monoxide is easier to measure than formaldehyde, and an oxidation catalyst reduces formaldehyde just like it reduces carbon monoxide. And so they use carbon monoxide as kind of the measurement tool to reduce formaldehyde. Because again, you go through this stuff, it's like they're not trying to reduce, well, again, they're not trying to reduce CO, they're trying to reduce formaldehyde. And again, if you read the long rule, it's like, they talk about how many millions of dollars it's going to save in lives as compared to the how many billion dollars, as opposed to the only hundreds of millions of dollars it's going to cost to upgrade all these engines. But anyway. So the rule came out on May 3rd, 2010, and the rule said you have 3 years to become compliant. You got until May 3rd, 2013. And back then it seemed like, that's a long time, but here we are. The rules, the rules go through these process, people see them, they make comments, they sue the EPA modifies the rules, they put them out for review, and then they make a new rule, whatever. So the rules changed somewhat in 2011, and then there's a bunch of more things going on, and the rule, the latest version of the rule came out on January 14th of this year. And again, for some utilities in some places, they're kind of like, they were lobbying the EPA to give up more hours under that emergency rule. Let me have peak shaving. Let me have just 100 hours of peak shaving. Let me do this. So a lot of the utilities here in the Midwest were trying to get that rule to be changed, and not until sort of January 14th, 2013, did the EPA kind of say, okay, here it is, I've ruled. We're not going to give you any hours to do that. And my understanding, not being in the middle of the arguments really, but listening to them, again, there's as many people from whatever, the Sierra Club or the East Coast where they have a lot more pollution problems or something, who are arguing against adding more hours as they were trying to add hours on and stuff. So probably an interesting process. So again, this rule just came out. The final version of the rule came out in January. And again, I think a lot of the utilities, a lot of the people in the, maybe the Great River Energy distribution partners across most of Minnesota were kind of hoping they were going to get some more hours. That didn't end up happening in this final rule. So, as I said before, the regulation is looking to reduce hazardous air pollutants, primarily formaldehyde, and it's trying to do that for existing stationary engines. So what's an existing engine? Well, the rule makes it really simple. It's an engine that was manufactured before June 12, 2006. And again, it's almost perfectly correlates, nothing perfectly correlates, but it almost correlates with when these tier rules started to happen. So kind of when they started making engines being tier 1 and tier 2, they're kind of saying, well, if you've got a new engine that's been kind of regulated under new source performance standard, you don't really have to, do this thing for NESHAP. So again, if you had in front of you, I know you don't, but if you had in front of you, all your any diesel engines you've got in your cities, and you knew what, had all the information, I knew when it was manufactured. It was like, okay, if it was manufactured after June 12, 2006, now you can really go to sleep. Because the stuff I'm going to talk about from now on doesn't apply to you. Because my engine's newer than June 12, 2006, so I don't have to, the NESHAP rule says the only thing you have to do is follow the new source performance standard, which your engine would have been purchased, under that, at that time. So, again, there's a bunch of things like, does this apply to me? It's like, okay, June 12, 2006. If I bought my engine, if that engine's got a date on it after that, then you don't have to worry about NESHAP. The really simple version of the story. So, again, I said in the new engines, the EPA's got a pretty easy job, relatively. They go to the engine manufacturers and they get them, whether it be 6, 10, or 12, or whatever them, how many engine manufacturers you want to talk about, they get them to follow the rule. But now with this rule for existing engines, it's really the responsibility of the owner and the operators. So all of you, all of us, our company owns generators that are on peak shaving as well. So, it becomes the individual's responsibility to deal with that. Now, my understanding is, I had a couple people talk about it here, but like in some of Great River Energy's distribution partners, Dakota Electric, Wind Value, who we were just talking about, Connexus. There's 26 distribution partners that Great River uses, for the retail side of what they generate for electricity, it sounds like they're coming out to the customers and giving you a form and say, I want you to sign this form. Do you opt in? Do you follow the rule? Or do you want to opt out and not follow the rule? So hopefully what we're going to tell you here is it'll help you understand if you can easily sign that paper and say, yeah, I'm okay, I can opt in. So one of the things, as I said before, one of the things is, if you go look at your engine and say, well, my engine was manufactured after June 12, 2006, you can go to utility, whatever, and say, I'm good with NESHAP. I mean, I can opt into anything. I follow the rule because the rule says I'm not going to do anything because it's after that date. So here's the other piece. I got one more slide. So if you're in this slide, and you listen to this slide, you can stop. If you're on a utility rate program and you have a non-emergency engine less than 300 horsepower, or if you only use your engine for emergency. So again, I'm not on a utility program, I only run my engine emergency, or I am on a utility program, I get savings from this, but my engine is less than 300 horsepower. The one warning, it's about 200 kW, but we've already found, 200 kW is right on the line. Some engines that are a 200 kW generator might have used an engine that's 310 horsepower. And another year, we've got this even with CAT, and 2 years before that, or maybe some other manufacturer, might have gotten a 200 kW generator out of a 290 horsepower engine.
Got one at 250.
250 is well, see, but 250 is good. I got a 200 horsepower engine, it's 250, great, that's less than 300. But what I'm worried about is if somebody says, I got a 200 kW engine and this doesn't apply to me, you gotta go look at your horsepower, and if it's 305, now this rule applies to you. 250, here, you're good, under 300 horsepower, this is you now. So if you got it, if you had all your information in front of you, you already did the date. Okay, I got my thing before, my engine was made before June 12, 2006, so I got to keep listening. All right, now I look at my next set of information. My engine is a 250 horsepower engine. Great. Anything less than 300, or my engine is not on a utility peak shaving program and I don't run it unless the power goes out, except for testing. Then all I have to do to be compliant with NESHAP, I don't have to install a catalyst. I don't have to do any reports to the EPA or any notifications. The rule says I have to do something. I should record the run hours. I should follow maintenance practices. It says you should change oil every year. You should inspect the air cleaners and belts and hoses. And you should keep records that you've done that for 5 years. So I think, in most cases for us, we'd say, well, this is the kind of stuff you should be doing anyway. And again, whether you change the oil yourself or you have, a service provider, Ziegler, or somebody else do it, if you've got Ziegler's doing it for you, they'd have the records of when they change their oil and stuff. The run hours, again, if you have service done, by a service provider, they're logging the run hours. If you're doing it, you'd probably run the log hours. So again, nothing too much. But again, you don't have to put a catalyst on. You have to go to the EPA. Someday, some crazy thing happens. The EPA comes to you and says, "Hey, did you keep the records on this?" You say, "Yeah, here's my records." I'm not sure when or why they'd ever do that, but that's what this rule has. So, again, if I have an emergency engine, or for those engines that are emergency that I own, or my engine's less than 300 horsepower, there you go. That's all you need to know. Now you can go to sleep. So now, if you have a non-emergency engine, you're on a peak shaving program, and it's greater than 300 horsepower, now you gotta keep listening. Sorry. Look at make sure there's any more donuts out there. Everybody's got this stuff, then you just get up and go have donuts now, because, yeah, don't tell them that. All right, sorry, they're supposed to be listening. Forced listening, sorry. So, again, if you are using your engine non-emergency, again, for most of us, a peak shaving program, with your utility, and it's greater than 300 horsepower, then these are the places where you need, really the simple answer is you need to install a catalyst. We haven't really found any place that has such low emissions that the engine doesn't need a catalyst. There might be one out there, but again, generally you have to meet the catalyst, and you have to you meet a specific level. It's like 29 parts per million if it's greater than 500 horsepower, and 23 parts per million if it's greater than 500 horsepower, and it's 49 parts per million if it's between 300 and 500 horsepower. That's just the part that says I really know what I'm talking about, but it's like way too much information. But generally, it's like reduced by 70%. So whatever your engine puts out 100 parts per million, you put a catalyst on, and now it puts out 30 or less, you've reduced it by 70%. You also need to have some monitoring system, monitoring the temperature and pressure on the catalyst to make sure that it's kind of keep making sure that your emission system still works properly. And then you need to close a crankcase ventilation system. Many engines already have that on, but if you don't, you can put that on. And then there's some more stuff about compliance testing and reporting you have to do with the EPA. Let's look at each one of those. So what I always say is like, Ziegler has emergency generators, and it's a Bloomington facility. You know, you drive up 35W right there by 94th, and all the bulldozers and stuff are sitting there leaning over the highway. And we're on Excel's peak shaving program. So our facility guys, probably not any different than a lot of you guys are. Somebody says, okay, this new NESHAP rule came out, and you know, it's going to cost I don't know, it's going to cost $50,000 to upgrade our generator. It's like, no way, I don't have the budget, I'm not going to do that. Forget it, I'm going to just not do anything. Okay, so what I like to say is you got these options. I mean, I came from Ziegler, and one option is if you got one of those old engines, greater than 300 horsepower, and it has to be upgraded to NESHAP, I'd say just get rid of the thing and buy a new one. Come on up after the meeting, I'll sell you a new generator. I got to do that, that's the advertising part. No, but that's not the cheapest thing to do because obviously that's more expensive. But that's an option you have to buy a new generator, upgrade. The second option would be, as I was talking about, our facility is to get off your utility program. And this, you know, these guys say, I'm going to opt out of my program. I'm going to get off the program. I don't want to put the money into this. And just like our facility guys, like, I'm not doing that. It's too much money. It's not worth it. I don't have the budget. Why would I do this? DPA, blah, blah, you know, no. Like, okay, I don't care. Then what happens next is he goes away and he looks up and says, well, what am I really saving on my utility bills? And again, these are estimate numbers, but he's like, I comes back and says, well, I'm saving like $20,000 to $25,000 a year on my utility bill because I'm on this program. It's like, well, if I get off the program, I'm going to pay $25,000 more this year, $25,000 more next year, $25,000 more next year. I mean, it's like, wait, I've just spent $75,000. So it's like, I guess I should put it in. And what I've found talking to people, and it depends on your utility program and how beneficial it is. I think a lot of the Great River ones are pretty good programs, better than like the Excel ones, but the Excel had programs too. And I kind of say, my estimate is it'll cost you 18 months to 36 months of savings. So you go back and look at your bills and say, how much am I saving? And somewhere in there it's like, you'll pay for this upgrade in somewhere between 18 months and 36 months. So you can get off the program and you can pay your high utility bills from now on forever, or you could upgrade the emissions and you could basically pay higher utility bills for 3 years and then go back to getting savings. So that's kind of how I think about it. And again, in our case, our facilities guys looked at it and said, well, no, I guess we're going to do this. I don't really want to, but we're going to do it because it makes sense financially. So I'm going to talk about that. So what does it mean to comply with NESHAP? So the rule, I said very much in the beginning, you need to comply by May 3rd, 2013. Oh, crud, that's like 2 months from now. And I haven't done anything. Well, yeah, that's a problem because nobody can, it's like such a short time right now. If you came right now and said, I need to do this, it'd be hard pressed, impossible to actually get equipment in and get it installed and all that kind of stuff by that time frame. Now, one of the things that the EPA did in this rule, and because they kind of ruled on this last piece so late, they kind of said, the EPA put in a provision that says that users have 50 hours of peak shaving that they can do, kind of in, let's call it, 50 hours a year peak shaving for 1 year. And that lets people kind of get a little bit of an extension. So, like I said, today, this is the way that we go about getting it done. It wouldn't be done by May 3rd. It would probably be done by June or July. And if you hadn't done 50 hours of peak shaving with your utility by then, again, you'd be fully fine with that because the EPA says for a whole other year you can go up to 50 hours of running. So, again, some of you got these opt-in, opt-out letters. You could right now say, I can opt into the program. I'm going to go give somebody a PO to get this thing fixed, upgraded for me. It won't get done by May 3rd, but it'll get done by July 3rd, August 3rd. And historically, I haven't really run on my peak shaving program many hours. Or maybe I've run some hours in that time. If I'm below 50 hours by August 3rd, I'm still fine, and I can still be on the program. Excel, 2 minutes, and that's the end. Wow. 4 minutes. All right, good. Perfect. So that if you have questions, you certainly can talk about. Mark knows a ton about that. The other thing you got to do after that, not before, you don't have to do it before May 3rd, 180 days later, do a performance test, do reporting, and ongoing testing. So let me just show you a little bit. A catalyst. A catalyst is like a catalytic converter in your car. It uses heat and the precious metals to convert one kind of exhaust chemical into another gas chemical. So I got a couple examples. This is a big engine. It's like a 2,000 kW engine. And this is what's been added on the outside of the exhaust pipe. One way to do it, and you see we left the guy in there so you can see how big this was. This is another example of an inline catalyst where this is the dual output of a cat generator, the exhaust catalyst, and the dual outputs going up into the sound system. That's an inline kind of solution. There are other solutions where it's just easier to take the muffler off and put a catalyst muffler combination. So here's one. The muffler was here just like that. We remove that, put the same kind of muffler in, the catalyst is there. Got a little hard to see, but this is an indoor one where there's a muffler right above the engine like that, and now this is a muffler and catalyst. There's a catalyst inside this, in the middle of this silencer. So after you've installed the catalyst, then what you need to do is have it certified, and this is something that there are companies out there that do it. The EPA has specific rules on how you do that. 3 one-hour tests. They take all this certified equipment, hook it up, measure the gas before it goes in the catalyst, measure the gases coming out the exhaust stream, and says, yep, it's been reduced by 70%. You gather up all that certified data, and you submit that to the EPA and say, look, it all works. Here's just a couple of pictures. Again, they're catalysts. The catalyst is right in the middle. Here's looking at the gas before the catalyst, looking at the gas output. It's just some test rigs on top of this, where the testing company goes and plugs into test ports right here, plugs into a test port there to measure. And then finally on almost finally on record keeping, you would need to track hours, but also these things have monitoring systems, greater than 500 horsepower, a monitoring system with a continuous monitor temperature and pressure. And then if you ever see an error from those things, the temperature or pressure has gone out of range, then you need to go figure out what's wrong, fix it, and note it as part of your kind of record-keeping process. And then the EPA wants you to send in notification semi-annually. And that really there's 2 versions of that notification. One is like, I ran for the last 6 months, I didn't have any deviations. The other one is, I ran for the last 6 months, and I had this deviation, and here's what went wrong, and here's how I fixed it. When my temperature sensors failed, I noticed it, I replaced the sensor, and now it runs fine. And those would need to be submitted by January 31st for the previous 6 months or July 31st for the previous 6 months. And last but not least, 2 minutes left, is the ongoing performance test. So that performance test you had to do in the beginning, if you have to do that once every 3 years. If you ran your engine a lot, that doesn't really apply to us, 87, 60 hours, but mostly for most people, if you ran your engine in 3 years from now, you'd have to again do that test again to show that all your emission equipment was working properly. So really last slide of this, just again remind you, new engines, Tier 1, Tier 2, Tier 3, Tier 4, NOx, particulate matter. Existing engines, knee shaft, Rice knee shaft, oxidation catalysts. That's where that goes. So again, my last one is like, I'm not from the EPA, and I'm not a lawyer and an emission expert, but I mean, again, it's a simplified version. If you find yourself on the edges of what I talked about, I mean, again, maybe you need to get some more expertise involved. But for most of us, it's kind of pretty easy to be right kind of in the middle.